Hello, everybody, and thank you for joining us. My name is Mark Lawatz. I'm the Vice President of Partner Success here at Mailprotector. I also owned or operated an MSP for about a decade before coming to Mailprotector. And we're going to talk about some of the basics that everybody needs to master when it comes to email security, and specifically how SPF and DKIM function and how they're implemented. These are very important protocols to just kind of help everybody make sure that they're using email a little bit more safely. So I think it's important to start with the reason why this stuff is so important. And it goes all the way back to kind of the beginnings of the internet. And email itself started at this time, and it was called SMTP, or Simple Mail Transfer Protocol. It was an open protocol meant to make it very easy for people to communicate across a closed network. And that closed network was ARPANET. So as far as authenticating people or who you're going to communicate, the network itself being closed is what authenticated somebody. So if I wanted to communicate with Scott or with Amy, and I sent them an email or vice versa, I knew that they were real people on this closed network. So mail itself was open, but the network itself was closed. Then when the internet itself became open and we had this global network that is amazing and interconnects all of us in many different ways today, the problem is now you had an open protocol on an open network. And spam began to rise as a major problem. And today, spam is more of a nuisance. We literally have threats coming into our networks via email that are compromising data, that are compromising individual users, and creating major business losses. So the entire network had to respond to that kind of behavior. And one of the ways they did that were through two protocols. And we're going to start with SPF first. SPF, or Sender Policy Framework, was designed to tell the receiving email servers whether or not that the person sending the email was sending it from a server that was authorized to send on their behalf. So SPF is really concerned about, is the sending server an IP address that is authorized by the owners of the domain? So looking at this, when a sender sends that email message, the receiving server is going to take a look at that sending address, the sending domain, and check with the DNS server where that SPF record is going to live to say, hey, I've got this email coming from this IP address. Is this IP address authorized to send an email from whatever that domain is? If it's good, then that's considered authenticated and the message makes it to the recipient. And if not, it's rejected, and based on the policy, it might get thrown into a junk folder or even rejected or bounced altogether. That's the basis of SPF. So what are the advantages there? Number one, right, you're authorizing IP addresses. So it does remove some of the problems around spoofing and phishing, or at least kind of the most obvious stuff, because it prevents somebody from just standing up a server in their closet or in a virtual environment and start sending emails from a domain without it actually being authenticated. So that does also increase the trust. So people that are receiving messages from certain domains can be a little bit more sure that it's at least coming from a trusted source because the IP address has been authenticated. And this information also integrates with other measures, which we'll talk about a little bit later, to kind of create a more complete picture of what is a trustworthy or a truly authenticated email. Now, there are some disadvantages here. Number one being the scope of this solution is based on IP addresses, and IP addresses alone aren't a guarantee that an email is going to be good or bad. You also have to learn or actually know how to manage DNS and then manage the DNS record itself. In SPF's case, it's a TXT record. So that creates a little bit of complexity. There's maintenance that goes along with that because you can't just put that record in there and feel like you're done. And it also does have some hiccups when it comes to how emails get forwarded. When those situations come up, then the SPF itself looks like it fails because of that forwarded email coming from a server that may not be a part of those authorized IP addresses. So call it a false positive or a strict policy just kind of getting in the way of some of those email processes that we've gotten accustomed to, that can create a little bit of headache for email administrators. DKIM, or Domain Keys Identified Mail, this was meant to kind of take things a step further. SPF, like we just looked at, was very simply based on the IP address of a sending email server. DKIM is now concerned with making sure that the email itself doesn't get altered or modified while in transit. So after it gets sent by the email server and before it gets to the receiving server, has anything or anyone in between change that message? That's a concern because, if you want to call it a man-in-the-middle attack, sure, but it essentially comes down to some type of compromised network or a compromised service grabbing a message, potentially altering the contents of it to change links or social engineer the recipient in some way that creates a problem. So DKIM was created as a way to try to combat that and make sure that an email message didn't change from its source to its destination. And the way DKIM works is, again, it's dependent on DNS, but it uses cryptography to make sure that the message isn't being altered. So when the sender sends that message, a private encryption key is used to create a hash, basically, in the email header. When the receiving email server receives that message, it compares that hash that's in the email header to a public key that sits in DNS of the domain that's sending that email. If that hash that is inside of the email header matches or authenticates against the public key, it's considered a healthy or unaltered email and it moves on to the recipient. If not, if that message is potentially altered and that private key hash inside the header does not match the public key, then it'll go to spam or, again, potentially based on certain policies, could even be bounced. So that's kind of the basics of DKIM. Once again, there are advantages to this, right? It's going to make sure that the email itself is authentic in terms of it hasn't been changed or altered since being sent from the original source server. That's very important because the integrity of a message is kind of everything, right? Like if you can't trust that the message hasn't been touched or altered by somebody, how do you know that whatever's being asked of you in that message is something you want to do? And the other advantage is the fact that it's using cryptography makes it much more difficult for somebody to jump in and even like try to alter or match those cryptographic algorithms to still try to pass it off as an authentic message. The disadvantages are somewhat similar to SPF as well. Number one, you got to understand DNS. So there is a little bit of setup and maintenance to DKIM management. You also have to manage keys. We'll touch on that a little bit later too, because the key management is not always in your control. It is often in the control of other service providers. And again, we have some compatibility issues. Sometimes service providers don't offer DKIM signing. So what does that mean? What's the implication of a message being sent without DKIM signatures? And it could also limit what is available to you as a recipient of emails, because most people are going to want their emails, even if they don't have DKIM. It's kind of amazing how often some of these protocols are not implemented either correctly or at all. And unfortunately, as email admins, we still have to account for some of that. I like analogies, and I think taking a look at snail mail is a great way to try to understand how SPF and DKIM function in comparison to snail mail that hopefully most of us are used to. So when we look at a piece of snail mail, we have the envelope itself that contains the contents of a message, in this case, a letter, and the letter itself has additional information and the contents or the email. So when we're talking about SPF, that is going to be the address on the envelope where that message or where this letter is coming from. What's important when you're looking at email and trying to understand whether an SPF record is valid or checks out okay or not, you got to make sure that you understand it's the what's sometimes called the envelope from or the envelope sender. That is different from the from address that you see in your email client. The from address in the email client is really nothing more than a display name. The envelope sender is just like what you would see on the from on the outside of the envelope of a snail mail. The DKIM portion is going to be that stamp or that kind of recognition that the post office puts on the outside of the envelope saying, yes, this was exactly the message that, or I'm sorry, the letter that we received. We've put it through our process and we have now delivered it. And, they put their little squiggly line or whatever that says it's now been delivered to your mailbox and the stamp is no longer good. So the DKIM is just that confirmation that the post office has processed it and this message has not been altered. So the contents can be trusted as well. All right, so what does SPF look like and how do we implement it? Again, SPF is a DNS record. It's a TXT record specifically. Every one of the SPF records will always start with this V equals SPF1. Then it's going to contain some tags, and we'll talk about those here in a minute. And it will always end with a policy tag, which says, whether it should be hard failed or soft failed, and I'll touch on that in a moment as well. So this is an example of a very simple SPF record that is including Microsoft's Exchange Online or Office 365 service, and also an include statement that is, one of Mailprotector's products, our secure email gateway product. What happens when the message comes to the receiving server? It's going to get checked against the SPF record. So if the email were coming from mailprotector.com, then we do use Office 365 for our email. We also send our messages out through a relay. So when that receiving server is checking the SPF record for mailprotector.com, these two include statements are going to pull up a whole bunch of IP addresses. Now, I'm only showing what the 365 include statement comes up with, and it actually points to another SPF record, which includes all of these IP addresses. If we also showed what this email service.io was showing, that would be another 32 IP addresses. That's really all the SPF record is meant to do, is to provide those IP addresses that are considered authorized to send emails on behalf of a domain. It's very important to know that the include statement is absolutely a requirement if you're going to be sending from any service that is going to send from your domain, because without it, the IP addresses that will be sending those emails are not going to be considered authorized or authentic. So there are some very important do's when it comes to the SPF records. Number one, you got to make sure that you're including all the sources of email that you use. All right, so the example we just looked at, it accounted for Office 365. Maybe you use Google Workspace. Maybe you're using some other hosted provider. Maybe you're using a web host for a small business, and they're using just the kind of the free email accounts that come with the web hosting. Their email servers that are going to send emails on behalf of their hosting environment, they will have include statements as well. Now, there's also situations that I still hear about where an organization might have real small, like on-premise server or even a virtual machine that does nothing but like an email relay, like a little Linux box that sends out email to the internet. And it's really there to be able to send emails from things like a multifunction device or a scan to email machine, maybe voicemail to email, could even be security systems, right? Video surveillance, physical door access kind of systems, anything that generates a transactional email, but using your or your customer's domain, then that one server, that IP address is going to have to be a part of your SPF record as well. So rather than an include statement, you can put in a tag that is IPv4 colon and then the IP address, and that's how you could authorize that individual IP address. Another thing that you want to be very mindful of is, because this is dependent on DNS, there are DNS limitations that could create a problem with your SPF record. Because let's be honest, in today's world, we're using more and more tools that rely on email, and that email could be coming from a lot of different services. Right? We've already said Microsoft 365 or Google Workspace. Then you could be using a third-party email security system. That's another place where emails can come from. Your marketing team might be using a customer relation management tool. You could be using a professional service automation tool that sends ticketing emails. Could have newsletters that go out from things like MailChimp or Constant Contact. Other systems. You could have a voice over IP system that is hosted by a third party, and their voice to email system is going to need to be included in that SPF record. So you have all of these systems that might be a part of that SPF record, but there's a limitation. You can only have 10 lookups, 10 DNS lookups in that SPF record. And if you go over that, your SPF record as a whole becomes invalid. It's not going to work for anything. So the good news is if you do have more than 10 DNS lookups, there are services out there that do what's called SPF flattening so that you can make sure that all of those IP addresses are a part of your SPF record and it remains valid despite needing more than 10 DNS lookups. So if you're in that situation, just go ahead and do a search for SPF flattening. There are tons of providers out there. 3 that we see a lot of our partners have success with are SendMarc, EasyDMARC, PowerDMARC. Those are just 3 off the top of my head that we hear about quite often. But it is very important because, again, if you go beyond that 10 lookup, that limitation invalidates the entire record. The other thing that we see often is the hard fail flag is not set. So you have this SPF record. In our example, we had that -all, which tells the internet, tells receiving servers that if the SPF check fails, consider that a hard failure. And in most cases, that's going to send the message to a junk folder, to a quarantine, and even in some rare cases, it'll bounce the message. That is the best practice. Now, if you're working with a new domain or you're making some changes that you're not sure if they're going to be quite correct, changing that flag temporarily to a -all creates a soft fail. And that basically tells the receiving server that, hey, if this fails, it's not a good thing, but we're not telling you that it is a terrible thing. So you decide what you want to do with that soft failure. It could be still deliver it, could be put it in junk. Like it's up to the receiving server then to do what they want with that soft failure. But again, the best practice is get to that -all flag, get to that hard fail as soon as you can. What are the things you don't want to do? So one of the first and most common mistakes I see with SPF records is people include the +A and the +MX flags. Those are very often just wasted DNS lookups because in today's day and age, many of us are using hosted email. Very few of us are using on-premise email servers anymore. And the +MX flag in and of itself is kind of a wasted lookup because if you're using Office 365, Google Workspace, for example, you will never, ever send an email from the MX record. Your MX record pointing to Microsoft or Google is not a source of outgoing emails. So there's no point in having it. And in general, that's going to be the case unless you have an on-premise server. That +MX flag is just a wasted lookup. Very similarly, the +A is also very often a wasted lookup because I don't hear of very many organizations hosting their own servers and services on premise with a public IP address that is going to send an email. So unless you really have that kind of use case, both of these flags are very often just a wasted DNS lookup. Another common problem we see is people create multiple SPF records on a domain. So instead of having a single TXT record, they'll have 2, sometimes even 3 for some reason. How that happens, it could be an automated tool that they didn't know added another record, or they just simply are still learning DNS and SPF management. But a single domain can only have a single SPF record because when email servers go to check that record, they're not going to know to check multiple records. They're only looking for one. So make sure that you don't have more than one TXT record that starts with that V equals SPF1. And then the final kind of don't is set it and forget it, right? Like SPF does need to be managed. At the very least, you want to take a look at it probably on a quarterly basis to make sure that it is still providing the IP addresses that your organization needs or your customers' organizations need. Because inevitably, someone maybe in marketing changes from MailChimp and they move over to Campaign Monitor. Great, there's probably reasons to do that, but you got to make sure that the SPF record takes that into account. MailChimp is out, Campaign Monitor's in, that's going to be a different include statement. So set it and forget it is just not a thing. And let's all be honest, we're IT. If you don't expect change in IT, you're probably pretty frustrated. So SPF is as kind of straightforward as it can be. It does need to be looked at regularly. All right, let's jump into DKIM. DKIM in some ways is actually easier to explain. It is a CNAME record in DNS, so a canonical name, because in general, it's going to point to the servers or the services that are going to provide that private key that creates this cryptographic hash in the email header. And then it's going to be compared against this public key, which is based on a selector. And that selector is, in essence, what the receiving email server is saying, hey, I got this email from Mailprotector. It's got this hash in it that is based on selector 2. So it's going to go and do that DNS lookup for selector 2 at mailprotector.com and compare that private key to this public one. So what does that look like? It's going to be different based on the email services that you're using. Some of the most common selectors are, Microsoft and Google. They're going to start with that selector 1 or selector 2 if it's Microsoft. And you'll generally see it be so like selector 1 dot underscore domain key dot mailprotector.com or some domain.com. That's going to be the host name for the CNAME record. And then the value is going to be that hash. That hash is going to be provided to you by the service provider. MailChimp, we talked about that one. K1 is their selector. SMTP to go is a very popular email relay, very often used for things like scan to email purposes, transactional systems, even larger scale bulk or newsletter services. And then HubSpot. HubSpot is a very common CRM sales tool. Now you'll notice theirs is HS1 and 2 dash, and I just put X's here. HubSpot is going to give you, through their interface, a custom DKIM record for your domain, for your instance in HubSpot. So this is a good example that it's not always going to be just a common selector. Sometimes it's going to be a custom one provided to you by that provider. So what are some of the do's for DKIM? Number one, make sure you're configuring it for any email source that supports it. Not all of them do, but if they do, you absolutely want to put that in place. Just a quick teaser, next month, I'll be talking about DMARC. SPF and DKIM are kind of the basis of DMARC. And if you don't have DKIM, it could make managing DMARC a little bit more frustrating. So anytime you're setting up an email service for the domain, make sure that you check for DKIM and set it up appropriately. Segue to that is make sure you're following the configuration instructions very closely, because like the example with HubSpot, it's not going to be the same. It's not going to be a single selector with a single value. It's going to be potentially customized, and you're going to have to run through some steps to tell their system, hey, create my DKIM signature so that I can put the information into DNS. And then the last thing is make sure that you don't have relays after the DKIM signing process. So for example, if you send an email from Microsoft or Google, and then you have maybe some type of email signature system that changes that message before it actually goes out to the internet. If you don't have it set up correctly, Microsoft or Google create that DKIM signature, and then they send it to the email signature system, which puts an email signature into the message. And now all of a sudden, that DKIM record is not going to check out okay because something changed the message before it got to the recipient. So like an email relay, or I'm sorry, an email signature system, you got to follow their instructions correctly so that that DKIM signature doesn't get altered by the signature. All right, so what are the don'ts of DKIM? Number one, don't skip this protocol. It is absolutely necessary. Most of the large email service providers out there, so obviously Microsoft, Google, Yahoo, Hotmail, Outlook.com, AOL. Yes, people still use those services. They are all really becoming strict about making sure that the authentication protocols of emails are implemented correctly. So make sure that you're taking these steps. And then again, just to kind of highlight this, don't assume that every DKIM selector is going to be configured the same way. Some of the services that you use are going to have custom configurations, so you want to make sure you're checking with all of them. All right, so real quick, this is the first episode in kind of a string of webinars we're going to do over the next few months. I think I mentioned it earlier. I'm going to be talking about DMARC next month, and it's really based off of what we just talked about with SPF and DKIM. So at the end of this, you're going to get a survey. That survey is going to have some information. If you have not registered for some of these other episodes, please, I encourage you to check the box to make sure you're registered for those. Thank you very much. I know we probably have some questions, so I'm going to jump into that.
Can systems like Zapier affect deliverability?
Oh, great question. Um, Short answer is yes, but it kind of depends what you're doing with Zapier. If you're using it to again like change a message after it leaves the email server that DKIM signed it, that potentially could invalidate the DKIM signature. So it kind of depends what type of automations you're building in Zapier. In and of itself, Zapier shouldn't cause a problem, but if you're generating messages that will come from Zapier systems, you're probably going to want to go to their help center or their support and find out if they have SPF and DKIM records that need to be added to your domain's DNS. Yeah, that's a good question. I kind of forget about some of those automated systems.
Can you set up SPF records and not set up DKIM records? If so, what is the reason and issues that can happen?
Yes, you can set up SPF and not DKIM. And most of the time, that's going to be because one of the service providers you're using to send emails on behalf of the domain may not be doing DKIM signing. That in and of itself isn't necessarily a problem. Sometimes, transactional systems, so think again, like scan to email, a voicemail to email, those types of emails generally won't have a DKIM signature, not unless they get relayed through a system that would then DKIM sign those. So it won't necessarily cause a major problem unless the receiving server is looking at things in a very strict sense and even potentially has a DMARC policy that says if this doesn't look right, get rid of it, bounce it, quarantine it, whatever that policy might be. So the DKIM, having an email without DKIM in and of itself is not going to make it undeliverable, but it does increase the likelihood that it might end up in somebody's junk or get bounced. This kind of gets into the DMARC portion that we'll talk about next month. But by and large, what you're doing with scan to email or kind of those transactional systems, your domain is probably going to be sending it to people within the same domain. So you should be able to control that a little bit better. But if you're doing a scan to email and sending it to an outside domain, then it can get a little sketchier. So DKIM isn't absolutely necessary to deliver every single email, but it is a best practice and it is something that most email service providers are looking for to make sure that they're minimizing the risks that people are seeing through email.
Is there a tool that can verify a client's DNS records are correct?
There are tools. So I think I mentioned a few of the websites like SunMark, EasyDMARC, on DMARC, I think is another one out there. They will have tools that will check for the valid syntax of these records, right? It'll check to see, does your SPF record, is it formed correctly? Does it stay below the 10 DNS lookups? Does it, kind of have everything it needs to function as an SPF record? But it's not going to be able to go as far as validating whether you have SPF set up for all of the different services you might be using, right? Because it's got no way to know that. It doesn't know if you're using MailChimp. It doesn't know if you're using HubSpot, ConnectWise, Autotask, Halo, whatever it might be. So in that sense, there is no tool that can validate that. You kind of have to understand what are all the sources of email that a domain has, and make sure that you include those and set up DKIM for those appropriate services. So yeah, I guess the long and short of it is there are tools that will check the validity, or I guess the correct syntax of those DNS records, but it's not going to guarantee to account for everything that you're using. You'll be able to find some of that through DMARC. And again, I'm kind of shamelessly plugging myself here to encourage everybody to show up next month where we'll talk about DMARC. And DMARC actually has tools and reporting that'll help you identify whether SPF or DKIM is missing something. MX Toolbox does have, and in fact, I think one of them is called the Super Tool, where you can put in basically an IP address or a host name, and then just choose different tests from a drop-down list. It's a fantastic tool to just use as troubleshooting. Some of those DMARC websites that I've been mentioning, they have analysis tools where you can like put in a domain and it's going to check and evaluate SPF, DKIM, DMARC, and give you some suggestions. So between the two of those, MX Toolbox and some type of DMARC website, you're probably going to get most of the information you need.
I had an issue with DKIM when forwarding emails from an old M365 tenant domain to a new M365 tenant domain. Mailprotector helped us write a modifier in the header that allowed deliverability.
Interesting. Yeah, it's kind of hard to talk about specifics without maybe going back and looking at what that situation was. Um, my guess is kind of using the reference of an old tenant to a new tenant. Microsoft, of course, has been updating their infrastructure. So it could have been a change in the cryptographic nature of the DKIM record that was being used in the old tenant. Um, so when some of those things change, the public key doesn't always come through, and Microsoft looks at that just as much as an email security provider would, a secure email gateway. So sometimes in a situation like that, you do need to jump into the Exchange Admin Center, maybe create a transport rule or a connector exception that basically says, yeah, we know that DKIM's not going to look quite right with a certain situation, so account for that because we trust that our, some other security layer is taking care of things. Sometimes that's going to happen with other services that are DKIM signing, but they're not doing it quite right or up to today's standards. And in those situations, you might have a similar situation. This kind of goes back to where you mentioned the disadvantages of these things are some of those complexities. It can be tough, especially if you don't know the basics of DNS management. A lot of people will even make a simple mistake like putting an extra, like a trailing space inside of a DNS record, and it just blows things up. So yeah, it's one of those things that sometimes a little bit of trial and error, unfortunately, is needed because you don't always know what's going to happen end to end when that email goes over the internet.
Is there a deliverability troubleshooting process you use or a standard?
Oh, that's a big question. Yes. So as email administrators and like for us as email security providers, what we do is we try to make sure that we understand the basics of the mail flow, right? So we'll take a look at where is the message coming from, where is the message going, right? What's the receiving server? And then we've kind of trained ourselves to look at the email header to understand what did it look like as it went across the internet. That's going to give you a lot of indication as to why a message may or may not be delivered the way you would expect. Beyond that, the kind of the basics of troubleshooting always starts with DNS. You want to make sure that the domain you're accepting a message from or sending a message from doesn't have the DNS records that you would expect, right? Whether it's MX, SPF, DKIM, etc. I think those are probably the two biggest troubleshooting processes is to understand that the DNS looks the way you would expect and get familiar with reading message headers or work with a vendor that can kind of help you do that when you need it.
Is it possible to set up DKIM if someone has a hybrid Exchange 2019 on-prem and Exchange Online?
For the Exchange Online portion, yes. The on-prem Exchange server will not be able to do it without third-party additions to that server. I'm probably not qualified to answer the question fully, to be transparent. In that situation, hybrid deployments can get very complex. So I would recommend reaching out to, to Microsoft support, or maybe, an organization that are experts in hybrid exchange deployments, to understand the implications of how to manage that. In general, what I recommend to most people is get your email into 365. It's the simplest thing to do if you're going to have that hybrid environment. Make sure that the hybrid exchange server is doing as little as possible. And what it is doing is basically internal email, right? Some of that transactional stuff like scan to email, because DKIM can't be added to an on-prem server. Microsoft doesn't support it. You would have to add a third-party solution to make it happen. And the little I do know about it, it gets a little complex and squirrely, and you might even have to jump into like IIS to make sure that it's getting that signature correct. And it's not easy. And I'm sure Microsoft kind of does it on purpose. Let's be honest, they want everybody in 365. So that might be part of it.
If you have an external sender whose IT does not fix their own records, does allow listing the domain in services like Google and Office 365 typically bypass their emails going to junk mail in all instances?
I can't say in all instances. I will say like our tool, so our cloud filter tool, if you put in an allow for that sender address or domain, yes, even a DKIM failure and SPF failure would be ignored because you are telling the system, I want those emails, regardless of what happened, with the exception of a virus payload, right? If a virus payload is found, all bets are off. That's going to quarantine. That's gonna be junked. If you have the allow rules in Microsoft or Google, I would assume that they function the same way. To my knowledge, any type of secure email gateway is going to function that way. Yeah. So I'll just real quick, I'll just say if you are a Mailprotector partner and you're on Shield, which is our zero trust email security platform, um, does not work that way in Shield because zero trust does not allow that type of functionality. So to kind of keep it direct to that question, yes, an allow rule in those platforms should allow the message through despite SPF or DKIM failing.
What about archive services? How does that affect DKIM and SPF? Because some of these cause deliverability issues.
Yep, great question. So it kind of depends on the archive solution, but I'll focus on the method that is used most often, and it's called journaling. So when you have an archive that uses journaling, when a message comes through, if it passes SPF and DKIM and it's going to be delivered, then in most cases that email will also be journaled. It's a special type of copy of the message that gets sent to the archive. The archive itself doesn't really care about checking SPF or DKIM because that's really happening at the receiving side, right? Whether it's a secure email gateway or whether it's Microsoft or Google accepting the message, that journaling step is going to happen after the message has been kind of checked out and considered okay. The journaling is kind of like a Xerox copy of a piece of paper, right? So you get a letter, you want to make sure that it gets filed away for record keeping. It's kind of like making a Xerox copy of that letter, sticking it away in a safe file box, and then the letter itself ends up on the desk of the person that it was intended for. There are other methods of archiving that can use APIs to reach into mailboxes in Microsoft or Google. And that's going to be a little bit different, right? Because again, SPF and DKIM have been checked ahead of time. If the message actually makes it to the mailbox, then the API will reach in, grab that message, and stick it in the archive. So in both cases, to give you kind of a short answer, archiving generally is not affected by SPF and DKIM. It's more of an effect on the receiving server and whether that message is allowed to get far enough for the archive action to take place.
Would you be able to elaborate on an ARC sealer?
Essentially, what ARC is, it's a protocol that allows a receiving server to receive messages that are forwarded or relayed from another third party, and it makes sure that that receiving server is going to accept the SPF and DKIM evaluation that was made by that previous hop. So secure email gateways, that's the most common situation, right? You're going to put something in front of Microsoft or in front of Google Workspace. Those messages come through that secure email gateway. They're getting checked for SPF and for DKIM and for all sorts of other stuff. So when that message is deemed to be good, and then it gets delivered to Microsoft or Google from that secure email gateway, Microsoft and Google might still be looking at the characteristics of that and might even try to do an SPF check against that message. Well, the last hop it's coming from is that secure email gateway, which is not going to be a part of the SPF record of that sender's domain. So it'll look like it's a failure. What ARC does is it establishes a relationship, thank you, authenticated received chain. So it creates a chain that tells the receiving server, Microsoft or Google, hey, if you see these IP addresses or you see these host names in the message header, ignore those because the SPF and DKIM has already been checked. It's all good to go. So go ahead and move on and take a look at whatever else you need to because those protocols have already been validated. So ARC is really intended to make the mail flow to these large email service providers flow more smoothly with the third-party tools that exist out there like Mailprotector.
How is Bracket working with SPF DKIM protocols?
Awesome question. So bracket encryption is going to take a message, and if it's deemed to need to be encrypted by Bracket, the message actually goes to Bracket, gets encrypted, and then what gets sent to a recipient is nothing more than a notification email that is coming from the domain bracket.email. Bracket.email has SPF records, DKIM, DMARC. It has all those authentication protocols configured so that when the notification message gets sent to the user, to the recipient, it passes all those things and the notification does arrive as expected. So that's kind of the main thing to know is when you send a bracket encrypted message, the message itself isn't what gets delivered. It's only a notification that is generated by the bracket encryption system. Hopefully I explained that clearly.
And Mark, would you just maybe just give a little context of what Bracket is for anyone who might not know?
Yeah, so Mailprotector has an encryption product called Bracket. It's one of the easiest, it's the easiest encryption tool on the market. Once you set it up, if somebody needs to send an encrypted email, they simply put brackets around the subject line and send it. There are no plugins, there's no installed software. It works from any device and any operating system. And then the recipient receives, as I mentioned, a notification. That notification allows them to jump into the Bracket portal to see that encrypted message. It is passwordless, uses digital fingerprinting for security as well as inbox authentication methods. So the security is still there without forcing anybody to jump through all the traditional hoops that we see with a lot of other email encryption processes.
For anyone who doesn't know, we have a free tool called Radar, which goes and checks all kinds of different things for your email security vulnerability. Mark, how does SPF and DKIM tie into Radar?
For those that are unfamiliar with Radar, it is a tool that allows you to put in an email address. Radar sends an email to that email address. The recipient of that will reply, which sends the message back to Radar. Radar then evaluates that entire email flow. And with that reply, it's also able to check whether that email and that domain have SPF configured correctly. Does it authenticate DKIM as expected? Does it have a DMARC record? Are there certain security functions that are set up in the domain itself? It's basically kind of like a credit score for your email security posture for that domain or that email address that you put into the Radar tool. So it's really handy as a way to just spot check. Do you have SPF and DKIM set up correctly for your customer, for your own domain? If you're out talking to a prospect and you're trying to talk about the importance of email security, right? Like most people don't want to talk about that. A lot of people don't understand it, let alone even care about it. So Radar is a great way to just have them run that right from their desk, right during the conversation. And when Radar gives them that report, that credit score like report, it makes it much easier to have the conversation of like, hey, wouldn't you want a credit score of 850 instead of like 620? Let me tell you why. And it's just a great way to kind of open the door to showing your expertise as an MSP and how important it is for something as simple as email to be set up in a best practice manner. Thank you, everybody, for carving out a little time and joining me. Hopefully this was useful. And again, please join us next month. We'll be diving into DMARC and tying this all back to the importance of SPF and DKIM. And we won't forget about that question about how do I use DMARC to identify and fix those things. So again, thank you, and hope everybody has a good rest of the month.